Good afternoon, everyone. So, what we were discussing in the last session? Sorry, rainbow. Acha, haan, we have not discussed about the rainbow, right? Means we have not written about it. We have discussed a little bit about it, that what is rainbow and all. Now, we have discussed certain portions like we have discussed about the blue color of the sky. We have also discussed about the blue color of the sea also, red color of the sun at the time of dawn or dusk. Yeah. And at the same time, we have also seen about the mirage formation. So these were the topics which we have discussed. We have discussed about refraction of light, dispersion of light, scattering of light, total internal reflections, and almost everything. Yeah. We have discussed about total internal reflection. Then we have discussed about this one portion, refraction. We have discussed about reflection, absorption, dispersion, scattering. I think these are the topics which we have discussed. Okay. We have also seen this one thing that if there is twinkling of the stars, it is because of refraction of the light. We have seen that if the early sunrise or delayed sunset is there, it is also because of refraction of light. We have seen that the colors which we see, it is because of reflection. If any object which is not having its own light, if we are able to see that, it is also because of reflection. Yeah. We have also seen this one part that if light is incident, there is also a chance that there can be absorption. This absorption can also lead to radiation. In the case of geography, you might have read about this radiation from the Earth's surface also. Yeah. So that radiation is just because of this absorption, and then after it is followed by radiation. Then we have discussed about this one thing, that dispersion of the light. When it is passing through a prism or a liquid droplet, it disperses into 7 colors. This dispersion is just because the light is getting refracted at different angle. Then we have got the 7 colors of white light Vibgyor. Then we have also seen this one part, that there is one thing also called as scattering of light. The scattering is because of the particles which are present in atmosphere. We have seen that during the time of sunrise or sunset, we see the red color of the sun. Whereas during the afternoon, the red color is not there. We are able to see the white color of it. We have seen that why the sky is blue, why the sea is blue. These are the topics which we have discussed. Then we were talking about this one part, rainbow formation also. In the case of rainbow, I told you that rainbow forms due to a number of coincidences. One of the coincidences that there must be a rainfall. Then only you will have the rain droplets. Okay. So there is first requirement that there must be a moisture in the air. There must be one thing called as moisture in the air. Then at the same time, the sun rays should make an angle of near about 41 to 43 degree with the raindrops. Yeah. So in that case, the angle of incidence also matters. The angle of incidence which is there, it also matters. Then we see that there is also one thing, that 3 different events have to take place simultaneously. One is first dispersion of light, then total internal reflection, and then there should be refraction of the light. These 3 things are possible only when the light is incident on this at near about 43 degree angle. Yeah. So then it gives rise to rainbow. When we talk about rainbow, rainbow is like an entire circular pattern. Rainbow is an entire circle. But we are able to see just half of it. Whenever we see the rainbow, we are able to see the half of it. Because we cannot see below the horizon. We cannot, like, if you are standing here, this is the line which is called as horizon. If you are standing here, this is the line which is called as horizon. We cannot see beneath it. We cannot see beyond it. So While the rainbow has been formed in this entire portion, we are able to just see this one portion. We are not able to see beyond it. If you go anywhere, if you stand on the ground, you will be seeing just half of it. But if you're flying up in the atmosphere, like let's say you are in a helicopter, and at same time rainbow has been formed, then you might be able to see the complete circle of the rainbow also. Or if there is a very tall building, like say 40 stories or 50 stories or 100 stories, from there also if you are seeing the rainbow, you might see more than like half of the part. Like you may be able to see more than half of the circle. It may be 270 degree, to 80 degree, to 90 degree. Okay. So it depends on what elevation you are. If you are high, like if you are on this helicopter or plane, you might be able to see the full circle. If you are on the ground, you will see half circle. If you are on like 100 story also, you might still be able to see the entire circle there. So rainbow always forms this full circle. Now, how many colors are there in rainbow? 7, but not always. Okay. It is all about whether the refraction and all other things are taking place or not. Okay. So it may not be necessary that you are getting all the 7 colors, because there may be dispersion of only a few colors. Others may simply pass through it. There may not be always a total internal reflection of all the colors of light. Whatever are getting reflected and then dispersed, you are able to see that. Generally 3 to 4 colors. If you see a rainbow, you are actually able to see 3 or 4 colors. It is a rare possibility where you see all the 7 colors. Generally in the images you see 7 colors, but when there is actual rainbow, you will be able to find 3, 4 or 5 colors. These are generally there in the environment. Yeah. So that is one part about rainbow. What questions you can expect? They can ask you that what are the factors which are responsible for formation of rainbow. Now again one thing, when the light is coming from rainbow, when the light which has been refracted and it is coming towards you, it may lead to formation of secondary, tertiary or n number of rainbows also. They can again get refracted or reflected, and then it can form other rainbow formations also. Okay. So that is one part. There is not always just one rainbow. Many such, like the droplets which are present in atmosphere, they can create multiple rainbows at the same time. But generally, you see only one, because rainbow is a quite a rare occurrence. All these conditions have to be met, that you have to get a raindrop just at 41 to 43 degree, and that is a rare possibility. So like these days there is continuous rainfall. How many times you have seen rainbows in this world? When did you last see the rainbow? 2 साल पहले. When did you see the rainbow last time? In reality. Not on mobile phones, not anywhere else, not in news channels. Okay. So you can understand from here, there is continuous rain and there is sunlight also. Despite that, you are not able to see rainbow, because it is quite a rare occurrence. Okay. If you are in remote areas, there is a higher possibility, because you are able to see in all the possible directions, and there is a possibility that you might be able to see some rainbow. But in cities, if you find a rainbow, then you should consider yourself to be privileged part of humanity. Okay. Those who have been able to see rainbow in real. Okay. Otherwise, it's very like uncommon now. You are not able to see the stars properly now. How you will see the rainbow? Most of the time you are looking at some shining objects. They might be simply some satellites of a Starlink. Okay. So when you are looking up in the sky now, there might be some satellites only. Okay. So that is one thing. Seeing these things is quite rare now. There is a lot of pollution, lot of scattering, so it becomes rare. Now there is two more portions which are remaining here. One is interference and diffraction. Interference and diffraction. Okay. These two things These two things were used to understand whether light is having a particle nature or a wave nature. Now just tell me one thing. If we are throwing a ball or a bullet through this hole, will it strike here or will it be striking at all the different parts? There, we are striking a ball, we are letting a bullet pass through this narrow hole. So where would this ball go? A. Will it be traveling to B option or C option or all the three at the same time? If we are striking a bullet, like suppose you have a ball, if you throw out of the window, will it go and strike one place or will it strike all the places? Only one? Okay. So if a bullet is passing through this narrow hole, it is going to just strike at one of the end. It is not going to spread. Okay. But in the case of light, what we see that if the light is passing through a narrow slit, if a light is passing through a narrow slit, it is not just going at one position. Rather than that, it is spreading in a large area. If the light is passing through a narrow slit, it is not just hitting this one part, it is getting like spread in this entire zone. So it means light is not following the particle nature. Light is not following the particle nature. Now just do one more thing here. Suppose that you have one bucket of water, and if you drop a rock here, if you have one bucket of water, if you drop a rock over here, you will find that some waves will be formed. These waves are going to travel in the entire bucket. These waves are going to be traveling in the entire bucket. This is one part which all of you have generally observed, that if a wave is formed, it is traveling in the entire body. Now, after going from the class, just do one more thing. Take a bucket of water, drop a rock in that, and then after observe the waves. You will find that, suppose a wave is formed, look at this wave at any one single point. You will find that from this wave, there is going to be generation of another wave at this point. If you are looking at this position, you will find that some waves are getting generated from here also. At each and every point, now suppose this new wave has been formed, there also if you will focus, you will find that a new wave is getting formed here also. A new wave is going to be formed from here also. So each and every point on a wave front is a source of new disturbance. Okay. Like when this wave is going, what is wave? Wave is an energy. And when this energy is passing through this medium, it is going to cause a disturbance at all the points. And wherever a disturbance is caused, from each point, a new wave is going to originate. From each and every point, there is going to be origin of a new wave. Now look at this one thing. Here we have seen that there is a light which is passing through it. We are assuming that it is a wave. Now see here, when this wave is passing through this area, from each and every point, new waves are going to be created. New waves are going to be created from each and every point. That's why the light will be getting spread. It is going to be spread in large area. From each and every point, a new wave is going to be generated. That's why even if a very small part of light, a very small ray of light is passing through a tiny hole, then also will find that there is going to be light in this entire section. Because light is spreading. It is spreading because it is a wave. From each and every point, a new wave is going to be created. and that wave is going to spread in the entire room. So that is one thing which we see here also, that from each and every point there is going to be a new wave which is going to originate and which is going to spread. Okay. So this one particular thing, this one bending of light at the corners, bending of light at a tiny edge or a tiny hole, is what we call as diffraction. Yeah. The bending of light at these narrow slits is what we term simply as diffraction. And this diffraction proves that light is a wave. It proves that light is a wave. So that was one experiment which was used to show that light is a wave. But then there was another experiment. And in that experiment, we have chosen two different slits. We have chosen two different slits. Okay. So what we see that from here also the light is going. Here also the light is going. So light is passing from both these narrow slits. And when we look at the screen, what we see that at some point we are getting bright patches, then we are getting dark patch, then again bright patch, then again dark patch, bright patch. We see that when we are taking two slits, the entire area is not illuminated. The entire area is not filled with light. There are certain areas which is quite bright. There are other areas which are quite dark. Just like this one, that there are alternate patches of dark and bright color. Some areas have become quite bright, others are dark, bright, dark, bright, dark. So this is one thing which we observe here. Now the question is why we have got it. It's fine that we have seen that there is diffraction of light. Light is spreading. But why we are getting alternate bright and dark patches? Why we are getting alternate bright and dark patches? Tell me one thing. This is one wave. And this one is second wave. If they meet with each other, what will be the result? Look at the orientation of the wave. At this point, it is the crest, it is the trough. It is the trough, it is the crest. Trough, crest. Crest, trough. If they meet with each other, then what will be the resultant wave? If there is crest, it is having trough. If it is having crest, the one is having trough. So ultimately, what will be the result? If we superimpose them, if we put them over each other, what will be the result? Will it be like a flat line? If we impose them over each other, if we are imposing them over each other, like suppose we are imposing them over each other, what will be the result? A flat line, because they are going to cancel out each other. They are going to cancel out each other. This is like minus value, this is positive value. Minus value, positive value. Okay. So they are going to eventually cancel out each other. There will be a flat line which will be result of it. Means both waves have destroyed each other. The both waves are coming from the same source. So they have same intensity. If they are opposite to each other, they are going to cancel each other. And if they are same, if they are having same orientation, like we are taking two waves of same orientation, if we superimpose them, will it be forming this structure? So there is one thing called as constructive interference, where both waves have interfered with each other and they have led to a bright pattern like this one. In other case, they have destroyed each other and led to a creation of a dark pattern like the second one. So that's why waves are interfering and leading to creation of alternate bright and dark patches. Those who are looking at this for the first time, don't worry, you don't have to give that in examination. You have to just understand one thing, that due to these experiments, it was proved that light is having a wave nature. From examination point of view, you have to just understand one thing, that light is having wave nature, light is having particle nature. Those who have done class 11th and 12th with science, whether bio or maths, I think you have gone through it. There is a very famous experiment, Young's double slit experiment. You have to derive all the calculations and everything from there. It is the Young's double slit experiment which has shown this, like light is having a wave nature. Diffraction is also showing the same thing, that light is having wave nature. So when we have to write, we will write only these two things, that light is having a wave nature as proved by diffraction and this interference. We are not going to write this experiment, but I'm just telling you that there were two experiments which was done to prove this part, that light is having a wave nature. Okay. So that is one part. But then there was a scientist, Einstein. Okay. And before Einstein, many people who said that light is not having a wave nature, light is also having a particle nature. But that was difficult time. You cannot say that. The accepted convention was this, that light is a wave. It was proved that light is a wave. Now you have to say something opposite of that, that light is a particle. So it was not the time when you can say these things openly. Like today you can say that earth is not round, earth is flat. You can say universe is very small. There is no challenge. No one is going to kill you for that. Yeah. But there was a time when you cannot say these things. When people said that earth is not flat, earth is round, they were given this home imprisonment. Yeah. When Galileo said it for the first time, that earth is round and sun is fixed, earth is orbiting, so he was given home imprisonment, that he cannot come out of his house. He cannot be teaching to the students. He was disqualified from teaching. When Tesla said that AC is better than DC, his entire factory was burned. His each and every inventions or discoveries were destroyed. Okay. So there was a time when you cannot say these things openly. Okay. So at that time, if someone has to say that light is having a particle nature, it was quite challenging for them. Many scientists have shown it in their experiment way before Einstein. In 1870s itself, in 1880s, 90s, many scientists have shown this, that light has a particle nature, but they didn't claim it. They didn't ask for it. They didn't show that light is having a particle nature, because they knew that if they say this, there will be a massive opposition and they might have to give up their research work. So many people didn't say anything about this. But in 1905 onwards, Einstein started saying this, that light is not just a wave, light also behaves as a particle. So Einstein was having like his own stature. He has already proved so many things. So Einstein was quite a reputed person. If he is saying something, then people will accept it. So he started saying this one thing, that light is not having this wave nature only, light is also having particle nature. And there was an experiment which was conducted by him to just show this. Okay. So that is famously known as photoelectric effect. Okay. And this photoelectric effect is the basis of the solar energy in the present times. The solar energy which we are having, or the LED lights which we are having, it is just because of the work of Einstein or the predecessors who were there. Okay. Those who have not claimed it but have like been showing it as part of their experimental results. Okay. But then no one said this, that light is having particle nature. It was said first by Einstein only. Now see here, how we can understand the photoelectric effect. Suppose this is a box and I'm giving you a hammer. Okay. Like suppose this is the podium and I'm giving a hammer to you and I'm asking you to break this. Okay. So I think all of you can easily do that. Okay. If I give you one hammer and ask you to break this podium, I think every one of you can do that. Okay. You might be working out a little bit. You might have got that extra strength. Okay. So you can break this podium easily with a hammer. But suppose I bring in a small child of 1 year and I give him the same hammer. If I ask him to strike it 100 times also, will he be able to do that? You are striking one time only and still this can break. But if I ask the same thing to a child who is of 1 year, can he break this podium? No. Why? He will not be able to apply that momentum. He will not be able to provide that momentum to this box or the force to this box to like remove it or to break it. Okay. Now a similar experiment was conducted without hammer. Okay. Here, in this case, there was use of red light first. Okay. There was use of red light on a very fine sheets of gold. A very fine plate, a very fine sheet of gold was taken, and red light was made incident on this. Okay. There was no electrons coming out of this golden sheet. Okay. Then what we see that the intensity of light was increased, the brightness of the light was increased. Even after increasing the brightness or intensity of the light, still no electrons came out of it. And then after, this red light was replaced by a blue light of lower intensity. A blue light was used, but of lower intensity. And then after what we see that when the blue light was used, the electrons came out. So it was not related to intensity. It means intensity is not responsible for the energy. Even if we are taking a blue light of less intensity, electrons are coming out of it. And when we are taking the red light, they are not coming out of it. So now the question was, why did this happen? Why did this happen that red light is not able to remove the electrons, but when we replace it with a blue light, it is able to like eject the electron out of the surface? What was the reason behind it? It was identified that both these things are made up of certain particles. It was said that light is made up of a packet. This is called as packet of energy. It was called as packet of energy, and at that time it was called as quanta. That light is made up of quanta, and quanta are particles, and each and every light is having different quanta. Red light is having different quanta, blue light is having different quanta. Because see one thing, both of them have same velocity. So light's velocity is always constant. The velocity of light is not changing. So what could change? Momentum is mass into velocity. So velocity is not changing. What could change? The mass. So then it was realized that blue light is made up of quanta which may be having higher mass or which may be having eventually higher momentum as compared to red light. Okay. So from this photoelectric effect, it was decided that light is made up of particle. Light is not wave. Light is made up of particle. Because waves energy depend on the intensity. Waves energy depend on the intensity. Like suppose when we are having the same, like let us say we are having the same podium. If waves are coming here, if the continuous wave of water hit this, then after a certain period of time, this will be broken down. If it is put in the, like suppose we are putting it near the oceans, and if waves are coming, maybe one wave will not destroy it, but after that subsequent waves are going to destroy this table, because wave energy is related to its intensity. It is related with its intensity. It is going to break it. But in this case, electrons are not coming out even if we are increasing the intensity. So here the light is not behaving as a wave. Light is not acting as a wave. Even if we are increasing the intensity, it is not leading to the ejection of electron. Electrons are not coming out. So then it was considered light is not a wave. Light is a particle. And then it was said that light is a particle made up of quanta. Later on, this quanta was called as photon. Later on, it was called as photon. So it was seen that the different light waves, they are made up of different type of quanta. They have different energy level. They are acting as particles. So on one hand, some scientists have proved that light is a wave. We have seen the wave property also. We have seen the particle property also. So light was having both these things. So finally there was a mediation, and that mediation was done by de Broglie. So de Broglie hypothesis came in 1936 around, and he said that light is both a wave as well as a medium, as well as a particle. When light is passing through a medium, it is acting as a wave. When light is interacting with a particle, it is behaving as a particle. So ultimate result was de Broglie hypothesis, which says that light has dual nature. When it passes through a medium, it behaves like a wave. But when it interacts with a particle, it starts to act like a particle. So light changes its nature. When it is passing through vacuum, it is acting as a wave. When it is passing through air or any other place, it is acting as a wave. But when it interacts with the particle, it starts acting as a particle. Okay. So that was one special thing which was seen in case of light. But it was not only limited to light. In 1950s, when we started reading the quantum, when we started discussing about the quantum mechanics, it was seen that like the light behaves as a matter, the matter also behaves as a energy. Okay. And it was seen that if you look at the electrons, the electrons are acting as a wave. The electrons, protons, neutrons, quarks, they are acting as a wave. If you closely observe the electrons, protons, or neutrons, or if you go in finer details like quarks, they are moving at an enormously fast speed. They are continuously moving at a very high speed. Okay. So inside our body, there is always a motion. Inside the air which you see, if we take one particle, like this is one thing which may appear to you to be static. But within this one pen, there are atoms, those atoms which have electrons, protons, and neutrons. They are oscillating on their axis. Within that protons, the quarks are moving at a much more higher velocity than you can imagine. So they, at that point, they are not acting as a matter. They are acting as a wave. So there is a matter in the wave and there is a wave in the matter. That is the part of matter-wave duality. That matter can act as wave, wave can act as matter. Now, when you look at yourself, you consider yourself to be quite large. But when you compare it in the universe, we are also oscillating in the same manner as the electrons and protons within an atom. Yeah. Like our motion, if you look at this, in the universe, we are also moving. Even if you are sitting at a place, then also you are moving. You are moving with the planet, you are moving with the solar system, you are moving with the galaxy, you are moving with the universe. So while you are in a state of rest, you are always in a state of motion. So from your reference or from reference of your fellow classmate or with reference to your home, you are in state of rest. But in actual, you are always in motion. So when you are not moving also, then also you are moving. Okay. So that is one part. Everything is in motion. The things which are inside us, the things which are outside us, each and every moment we are in the motion. Like, look, just imagine this. If someone is seeing us from another galaxy, they will assume that these people are moving at a very fast speed. They're moving at a very fast speed because the entire earth is moving, the entire solar system is moving, the entire galaxy is moving. So if you look from outside, we are continuously in motion. But in our state of reference, we are in a static position. Okay. So it is all about the reference, that what is the point of reference from which we are calculating. So matter is also wave, wave is also matter. That's why matter and wave are together considered to be one part of universe that represents only 5% of universe. Okay. The entire matter and wave means all the energy which is there, all the energy which you know, like the wave energy, tidal energy, gravitational energy, electromagnetic, all the things which you know, the strong nuclear force and everything, they are just 5% of the universe. All the stars, planets, everything combined together. Yeah. So this is one part, what represents the wave and particle nature of light. Write about it. First, rainbow formation. In rainbow formation, we have written the conditions or not? Achha, write down this. Rainbow is formed in the following conditions. Rainbow is formed in the following conditions. First, there should be presence of moisture in the atmosphere. Second, there should be sunlight. रात में कभी आपने रेनबो देखा है? So there must be presence of sunlight. Third part, the sunlight should be incident. The sunlight should be incident on the water droplets at an angle of nearly 43 degree. At an angle of nearly 43 degree. Then in these conditions, there is a possibility, that there would be dispersion, total internal reflection, as well as refraction, of the light rays. There is a possibility that there would be dispersion, total internal reflection, as well as refraction of the light rays. This will lead to formation of rainbow. This will lead to formation of rainbow. Achha, there is one thing. Like suppose that if there is a normal artificial light or moonlight, Can it form rainbow or not? If we provide all the condition, can it form rainbow or not? It might still form the rainbow, but it will not be visible. Like the light intensity should be that much properly that it can form the rainbow. Like if we create an artificial sunlight thing here, or we can create the same amount of energy here, and if it is passing through like any such rain droplets, then we can see the rainbow. But if the moonlight, if we consider the moonlight, can you see all the things in moonlight? Can you read in the moonlight properly? See, there have been people in the world who have been reading in moonlight. Okay. And then you are getting all the light and then you are not reading. Okay. May have heard these stories that we have read in street lamps, we have read in moonlight. Okay. So moonlight is not only for dinner. Okay. It is also for a study. Whenever you get the moonlight, you can go for the study also. Okay. So write down this one part. Rainbow is always circular. Rainbow is always circular. But we are able to see just half of it. नटराज के स्केल में रेनबो दिखता है. That is not rainbow, that is reflection of the light. Like if you pass it through a prism also, then also you will find 7 colors. Rainbow is formed only in a sky. It is not that if you are seeing through a scale and if you are receiving 7 colors, so that is not rainbow. Okay. Rainbow is formed in the sky in these conditions. But you can see this dispersion of light through a scale also, through prism also, through water droplets also. But rainbow, the full formation happens in the case of sunlight only, in the case of sky. Otherwise, just dispersion can occur anywhere. Like I can show you the rainbow here also. I have to just find a image of rainbow. And then I will show you. Okay. So that is different thing. Now, write about the next part, the particle and wave nature of light. Particle and wave nature of light. In the Young's double slit experiment, in the Young's double slit experiment, and through diffraction of light, and through diffraction of light, and through diffraction of light, it was proved that light is having a wave nature. However, in the photoelectric effect, Einstein concluded that in the photoelectric effect, Einstein concluded that light is having a particle nature. Light is having a particle nature. Change the para, next one. Later on, de Broglie although D is written with a small, but you can write it capital also. Later on, de Broglie gave a hypothesis Later on, de Broglie gave a hypothesis that light is having dual nature. Light is having dual nature. When it is passing through a medium, when it is passing through a medium or vacuum, when it is passing through a medium or vacuum, it behaves as a wave. It behaves as a wave. But when it interacts with another particle, it acts as a particle. It acts as a particle or matter. Just give a small heading, matter wave duality. Matter wave duality. It is seen that, it is generally observed that at subatomic levels, particles behave as a wave. Particles behave as a wave. In the same manner as light behaves as a matter. So this is one part about light. Okay. Now, we are going to start with the next theme, which is going to be with respect to electricity and magnetism. Achha, just one more thing, sound also there. Let's discuss about the sound first. It is a small topic. Okay. How do we get the sound? Vibration. So sound is what? Sound is an energy. Sound is an energy. It is a wave. Okay. So sound is an energy which is produced due to vibration. Okay. Whenever we have vibration, there is going to be a sound. So in the universe, there is sound or not? There is generation of sound in the universe or not? There are two things. One is generation of sound, one is propagation of sound. Both are different things. Generation of sound can simply happen if there is the vibration of particles. The energy which is generated is called as sound energy. Like suppose that you are able to see, you are able to listen to certain things. Okay. You are able to listen to certain things which you call as sound. Okay. Which you call as sound. Like sound is giving you a sensation that you are hearing something. But try to imagine sometimes, try to see this sometimes, when you are listening to the things, try to see this one thing. All this listening is going up in your mind only. Your mind is speaking up to you that you are listening these sounds. In fact, sound as such is not existing like which everything can hear. There are a lot of sounds in this room itself, but you are able to hear only a proper frequency of it. You are able to hear just one part of it, 20 hertz to 20 kilohertz. Okay. You are able to listen to only this frequency. Apart from this, if any other frequency is being generated here, your ears and your mind is not able to decipher it. So it doesn't mean that there is no such sound which is present here. There can be other sounds also, which might be present in this room, like there are so many bacteria and others, they might also be communicating to each other. There may be many insects which are communicating to each other. Some of them may have sound less than 20 hertz. Some of them may have the sound more than 20,000 hertz or 20 kilohertz. They are being generated in this room itself. But you will not be able to decipher it because we have a limited part. We have a limited capacity that we can decipher. We can decipher only those sound range which are between 20 hertz to 20 kilohertz. If the frequency is between this, then only we can decipher. Otherwise, we will not be able to understand what sound is there. So sound is a energy of different capacity. But we are able to listen to just this one part. Like electromagnetic wave starts from radio wave to gamma waves. But we are able to see just a very small part, 400 nanometer to 700 nanometer. Only this much part. So we are not able to see radio waves. We are not able to see the infrared, not the ultraviolet. We are not able to see gamma rays or X-rays. Have you seen X-ray? You may have seen the machines. You may have seen the flash, but that flash is not X-ray. That flash is just to give you a satisfaction that the machine is working. Okay. Otherwise, you will not believe it. Like suppose you go to a X-ray center, and you have asked them to take a X-ray of your bone. If there is no flash, you will simply say that machine may not have worked. How we will get to know that if X-ray is working or not? Yeah. So that flash or that sound which is added, it is an additional thing, just to give you one understanding that okay, X-ray machine is working. Otherwise, you will not believe it. Yeah. So that is the same thing here. Yeah. Like sound is getting generated, but you are able to listen only between 20 hertz to 20,000 hertz. Yeah. So that is the range of frequency, 20 hertz to 20 kilohertz, which we are listening. Now, is sound there in the universe or not? Of course, sound is there. But there is one thing. Sound cannot be propagated without a medium. Sound is a wave which always requires a medium for its propagation. It cannot travel like the light wave. Light wave can travel without a medium also. Light wave travels throughout the universe without a medium. But what we see that sound wave cannot do that. Sound requires solid, liquid or gas. Like these are three common states of matter. So sound requires the existence of all these three things for its propagation. It can be solid, it can be liquid, or it can be gas. But sound requires a medium. So this is one another part. It always requires a medium. It always requires a medium. It is produced due to vibration. That is another thing which we know about sound. Okay. Now one thing. When we are talking about sound, there is one very interesting thing about sound, that sometimes we are able to hear the echo. We are able to hear the echo sometimes, and while other times we are not able to hear the echo. So why does this echo takes place? If you have gone to any auditorium, or if you have gone to your college classrooms, the long classrooms, the large classrooms which are there. If you speak from one end, you will hear your voice multiple times. Yeah. Or if you go to any such seminar or auditorium room, you will hear that reverberations many times. You will hear that echo many times. So the thing is, why do we hear the echoes, and why we don't hear the echoes? One more thing. When we are talking about sound, can there be reflection of sound? Like in the case of light, we have seen that there is a reflection of light. So can there be reflection of the sound? Like suppose how the sound will be reflected. Like I am saying something. That sound will be going to the walls, it will be going to the roof, to the ground, to you also, okay, to the camera also, and then it is returning back. So is there going to be a reflection of sound? Tell me one thing. If the wave of water, what is reflection? Bouncing back, coming back? If the wave of water is like colliding with a surface, does it comes back or not? If you are throwing a glass of water towards a wall, when it collides with the wall, will it come back or not? It will come back. So when there is a reflection of the water wave, why it will not happen in case of sound wave? All the waves are going to work in the same manner. So there is going to be a reflection of sound. That is one thing. Second part, will there be a refraction of sound? Will there be a refraction of sound? What is refraction? Refraction is when a wave is able to cross one medium to another medium. Like suppose that if you are sitting in your room and if there is a procession going outside, if there is any DJ box outside, does the sound reaches to you? Even if you close the doors, does the sound reaches to you? So it means the sound is crossing the barriers of the walls and it is coming up to you. It has started coming from the air medium, it has passed the walls, it has reached up to you. So there is always a refraction of sound. Is there going to be a absorption of sound? Absorption of sound? Now just do one thing. You might be having some speakers, some laptops, some mobile phones. Yeah. So just start playing music for 1 hour or 2 hours. Do you find that your speaker get heated? Or if you have kept it over some surface, does that surface get heated? If just take one thing, take one speaker box, put it towards the wall and keep it like on for 1 hour or 2 hours. Will the wall become heated or not? If you have kept it on a table also, the table will also become slightly heated. It's not that it will reach 100 degrees Celsius, but it will be somewhat heated. Okay. So why it is getting heated? It is absorbing the energy. That energy is getting converted into heat. So there is always an absorption of the energy. There is also going to be the absorption of energy. So light is following the same, sound is following the same thing as the light. There is a reflection also, there is a refraction also, and there is a absorption also of the sound, just like the light. And from here itself, we are going to see the case of echo. We are able to hear the same sound more than once. That is what we call as echo. Echo is just one thing. That if you are able to hear the same sound more than once, that is echo. If you are able to hear the same sound multiple times, that is called as reverberations. Okay. So why we are having echo or why we are having reverberations? Why do we hear it? Like right now, you are sitting in this room. Are you hearing the echo? Or suppose those who are watching online, put on the speaker mode. And then like in the entire room, are you able to hear the echo? Many of you may not be able to hear the echo. And if you are sitting in a large hall alone, then you might be able to hear the echo. So the question is why and why not? Yeah. That is all about our mind. Mind has a role here also. Whenever we are listening a sound, we have the sensation of sound for 0.1 second. Like suppose you are listening any sound, like right now if I'm saying sound, so this word sound has reached to you from multiple areas at the same time. if they are reaching up to you within 0.1 second, you will hear only one of them. You will not hear more than that. But if that same sound is coming to you after 0.1 second, you will hear multiple sounds. Okay. Like if I have said sound one time, then in that case, if all the sound wave has reached up to you within 0.1 second, then despite having different sound waves, you are listening to just one of them. Means within 0.1 second, we can hear only one. We cannot hear more than that. And if there is a gap of more than 0.1, then you will be able to process more than that. Okay. So what we see that, like suppose what is the speed of sound? What is the speed of sound in air? Depends on temperature, depends on humidity, density. Okay. On an average, let us assume that it is 340 meter per second. Okay. It is approximately 340 meter per second at 27 degrees Celsius room temperature and normal humidity. Okay. Approximately 340 meter per second. According to temperature, according to humidity, it is going to change. Okay. So let us assume how much distance it will cover in 0.1 second. If its speed is 340 meter per second, so in 0.1 second, how much distance it is going to cover? You have to qualify for CSAT also. If you go by this speed, it is simply 34 meter. Okay. So you have to just divide it by 10. It is 34 meter. Okay. So if the sound wave is traveling more than 35 meter or more than 34 meter, then you will hear the same sound twice. If the sound wave is traveling more than 34 meter, then you will hear the same sound twice. Otherwise, you will not hear it. Okay. But subject to multiple conditions. Okay. Like suppose a person is here sitting in an isolated room. A person is here sitting in isolated room. There is also a speaker. From this speaker, the sound is reaching up to this wall also, and sound is reaching to this person also. Okay. When the sound is going to this wall, it will return back also and will come to this person. Suppose if this distance is, let's say, 15 meter. If this distance is 15 meter, how much distance will be traveled by the sound? 15 up, 15 down. So total distance will be 15 plus 15, that is 30 meter. So will it take more than 0.1 second or less? It will take less, because in 0.1 second it can travel up to 34 meter. Here they have to travel only 30 meters, so it will take less. Now suppose we increase the distance to 18 meter. Now what will be the total distance traveled by sound? 36 meter. In second case, when we change it to 18 meter, it will be 36 meter. So will it take more than 0.1 second? So now it is going to take more than 0.1 second. And in that case, the person would be able to hear the same sound twice. Okay. So echo is not about the distance. Like in some books, you will find that it is written that if you are at a distance of more than 17.2 meter from the obstacle or the obstruction, then you will hear the echo. Okay. But it will happen only and only if the sound speed is 343 meter per second. Okay. It will happen when the sound speed is 343 meter per second. If the sound speed is 330, it can be at a lesser distance also. If the sound speed is 360, so then it may not occur. Okay. So it is not about the distance, it is about the sensation of the ear. But our ears can process just one sound in 0.1 second. If you remember this one thing, then you can always calculate when the echo will be formed and when it will not be formed. That is one part. When you go to a movie hall, not for watching Sayara movie, anything else. Yeah. So when you go to the movie hall, then you will find this one thing. You are not able to hear the echo. Have you heard echo in any movie hall? If you have heard, then change the movie hall. Yeah. Because that movie hall has not been built properly then. So if you go to movie hall, you don't hear the echo. Even if the distance is more than 17 meters, then also you don't hear the echo. Why? It is about the surface of the wall. The movie walls, you will find that there is like they are having some cloth, some like cotton, or some of the dampeners which are fixed to the wall. Even on the floor, you will find that they have like they have done carpeting of the entire floor. The seats which are also there, they're having cushions. The entire roof is having cushions and all. They are making it so that there is lesser and lesser reflection of the sound. There is going to be more absorption or refraction of the sound and less reflection. So as a result of that, you are able to hear the sound just one time. Now, if you are going in an empty room and if you are like saying something, you might be able to hear the echo. If there is no cushioning, if there is no dampening, yeah, just go in any empty room. If you say something, you will hear your echo. But if there is a proper dampening done, if there is a proper cushioning done, then you will find that there is lesser and lesser chances of echo. So this is one part. Why do we hear the echo or the reverberations? Okay. So write a little bit about it. Write this. Sound is a form of energy. Sound is a form of energy. It is a mechanical wave. It is a mechanical wave. It is a mechanical wave, which means it requires medium for its propagation. It requires medium for its propagation. Okay. Third part, it is produced due to vibration. It is produced due to vibration. Next part, human ears. Human ears are able to process. Human ears are able to process sound wave, sound wave of frequency. Human ears are able to process sound waves of frequency 20 hertz to 20 kilohertz. 20 hertz to 20 kilohertz. Then sound wave can also go through sound wave can also go through reflection, refraction, and absorption in the same manner as light. In the same manner as light. Then give one subheading, echo. It refers to the condition, where we are able to hear multiple multiple reflection of the same sound, where we are able to hear multiple reflection of the same sound. So just 1 minute. You know, how do we hear actually? Like the sound, how do we interpret it? Our ear walls are there, but how do the ear walls tell us about this, that some sound has been generated? Just see this one part. Like if I am saying something, that sound is a wave. So you are hearing 4 different words. Sound is a wave. Okay. Different people can say it in different manner also. So when you are hearing this word, you have to understand it. It is not like the sound like this, what you hear in your head is actually traveling to you. What actually happens, that the particles of the medium are vibrating. These vibrations are reaching up to your ear. Your ear is interpreting that vibration, and according to that vibration, we are interpreting the sound. It is not actually the sound which has come to you. It is the vibration of mediums which is coming to our ear. Our ear is just processing that vibration, and according to that vibration, our brain is interpreting that a sound like this has been generated. So when we have studied this one part, that what is the brain doing, what are the different portions of brain doing, in that I have told you that in the frontal lobe itself, we are interpreting the sound. So that interpretation goes like this, that in actual, there is vibration which is going through the ears. The air is also reaching up to ears. The particles of the air are vibrating, and we are interpreting that vibration only. So suppose that you may have heard this one thing, that the walls also have ears. But when you put your ears to the wall, are you able to listen to something? No? Okay. Why? Because the particles of the solid, they are not vibrating and going inside your ear. If the particles of solid can go inside your ear and can cause the vibration of eardrums, then you might have been able to listen to that solid also. But solid is not like vibrating and going inside our ear. The air is vibrating and we are interpreting the vibration. So the work of brain is really very tough part. You can understand, like the same word can be said by different people in a different manner. Like all of you who are sitting here, you can say the same word sound in different manner, and when anyone is listening, they will be able to identify the sound of each and every person. You will be able to distinguish between the sound of each and every person. So that is the ability of the mind, that if 20 people, 30 people, 100 people are saying sound, each of them are going to have a different tone, a different vibration, a different energy. And our brain is able to interpret all these things and distinguish between it. That is the role of brain. And that is how actually we hear things. So it is not that some sound is created and sound is coming to us. It is the vibration which is created in our surrounding, and that vibration is felt by our body. And according to that vibration, we are interpreting the sound. So sometimes you may have seen this, that when the wind is moving with a very high speed, you are not able to hear the sound. If the wind is moving at a very high speed, is there some interference in the sound? Yeah. Like suppose you are sitting here. Yeah. We are putting a fan in the middle of it, and a person is sitting from other side. Will you be able to hear properly? there will be some deflections. So why it is? Because that vibration is also going to be affected by the kinetic energy of the particles. That's why when you have too much of wind or anything, you are not able to get the sound properly. Sound has to be really very powerful to reach up to you during that times. So this is one part, right, about echo. Our ears have a sensitivity of 0.1 second sensitivity of 0.1 second for a particular sound. It means within 0.1 second, our ears are able to identify just one sound wave irrespective of how many sound waves are reaching to us. Irrespective of how many sound waves are reaching to us. When the sound waves from same source reaches to us after 0.1 second, when the sound waves from the same source reaches to us after 0.1 second from multiple directions, then we are able to hear echo. There is one more thing in sound, like two things which we have to see here. One is a phenomena called as Doppler effect, and there is another thing called as ultrasonic sound. Okay. So first, let's see about this ultrasonic sound. Okay. Ultrasonic, if we talk about this, ultrasonic means sound above 20 kilohertz. If a sound is above 20 kilohertz, then it is simply called as ultrasonic. Now tell me one thing. We are using ultrasonic waves, ultrasonic sound, to detect the fetus in case of pregnancy. In case of pregnancy or in case of any such body abnormality, we are using this ultrasound. Ultrasound clinics are all over the place. Yeah. So we have so many ultrasound clinics. They are being used to diagnose any such fetus abnormality or simply to detect the fetus or any other problem within the body. So ultrasound is having frequency more than 20 kilohertz. Now tell me one thing, if we are using it for detecting the fetus, will it not cause harm to the eardrums of the baby? If suppose a ultrasound is being generated here, so for how long you can listen to it? For what time you can listen to ultrasound? For how much time? If I keep a source here and I start generating ultrasound, So up to what time you can tolerate it? सुनाई नहीं देगा. So will it affect our ears? That is the main thing here. Ultrasound is not a loud sound. Ultrasound is a sound of higher frequency. It is not a loud sound. The intensity of sound is measured in decibels. Okay. So that is a different thing. Intensity is different and frequency is different. This is a sound of higher frequency, not of higher intensity. You can make it of higher intensity also, then it will be harmful. But in general, ultrasound can be having the same loudness as we are talking right now. Okay. It means it is having a normal like intensity of 50 to 60 decibel or even less than that. So intensity is different, frequency is different. So what we see here, that when we are talking about ultrasound, it is not going to cause any problem inside the body as such. If there is a continued exposure of very high intensity, it can damage some tissues in the body, it can damage some cells in the body. Because when it is passing through the body, it is an energy. And when we are subjecting our body continuously to some energy, there is going to be some exchange of energy. And that exchange of energy can damage cell or tissue. But as such, it is not going to cause hearing loss. Because it is not a thing which we can interpret. Like infrared waves are here also. But can you see them? When you go out in the sunlight, there is ultraviolet also. Every day, if you go out in sunlight, you are continuously getting exposed to somewhat amount of ultraviolet light. Yeah. Ultraviolet light is continuously there. You cannot see it, but you are continuously exposed to it. In same manner, when we talk about ultrasound also, ultrasound is continuously there in the environment, but it is not of higher intensity. It is not having high decibels. So that's why ultrasound is used for this purpose. But remember one thing, this can cause vibration. This means it is having higher frequency. It means when it is passing through the medium, the frequency, the vibration will be much more higher. So this gives an opportunity to diagnose different part of the body. It can easily pass through most of the part of the body and we can detect any abnormality in the body. It can get reflected also, it can get refracted also, it can also be absorbed. So like the general sound, ultrasound is also reflected, refracted and absorbed. And accordingly, we get the different parts of the body. We get the information about different part. Now see here, what is the use of this? One use is health, you know that, health diagnosis. We know that one part, that in health diagnosis we are using it. There is another section. Ultrasound is also used for cleaning of pipe. Not the normal pipes. The cleaning of ultra sensitive pipes. Like suppose that we are having so many data servers. From time to time, we need to clean them also. But how do we clean them? Can we throw water in them? So by the way, you will have to understand one thing. The data servers are almost completely immersed in liquid. They are not immersed in water, but they are immersed in liquid just for transferring the heat. But to clean them, means the computers, normally you cannot put your mobile phone in water. You can try sometime at your risk, but you will find that after that you will have to take a new phone. You cannot put your laptop ever in water, but the data servers which are storing your data, like suppose you have made a Facebook profile or Instagram or WhatsApp or anything. So that data is being stored in a data server which is completely immersed in some liquids just to maintain the heat and everything. Now, when we have to clean them, in order to clean them, we are using ultrasound. Because ultrasound, when it is passing through these, like suppose there is a pipe, if ultrasound is passing through it, it will cause vibration. If any dirt particle is associated with these pipes, due to vibration, they will fall down. And when they fall down, they can be taken out through vacuum. So they are also used in cleaning of sensitive equipments, okay, like data servers and all, or the cables, the underground cables in the sea and everywhere. We are having internet through cables, not through satellites. Yeah. So when we are having the internet through these cables, they are also being cleaned by these things. They are also being cleaned by the ultrasound. Ultrasound is also used for detection of fault in the railway lines. Okay. Like suppose we have a railway track. Suppose this is having a length of 2000 meter. It is having a length of 2000 meter. And let us assume that the speed of sound is 1000 meter per second. So we have got a new track which is like created just now, and we are passing a ultrasound through it. How much time it will take to return back? How much time it is going to like pass through it and return back? The length is 2000 meter. 4 seconds, like 2000 up, 2000 down. So in total 4 seconds, it is going to take 4 seconds. Now let us say that there is a fault in this track at this point. There is a fault in this track. It has broken down. Let us say at 1000 meter, it has broken down. Now how much time will sound take to return back? 2 seconds? Okay. So if we get this part that within 2 seconds, the sound has returned back. So can we guess on the basis of that there is some fault in the railway track? Now, you also know one part, that this speed depends on the density. If the density becomes lower, the speed of sound will also reduce. Let us say its density has reduced, and the same, it is complete. It has not broken down, it is complete. And the sound is coming back in 5 seconds. Instead of 4 seconds, sound is taking 5 seconds. So on the basis of it, can we understand the speed of sound has decreased? And why would the speed of sound decrease? Density would have been lower. Yeah. So on the basis of it, can we judge the quality of the track? That now it is not so much, it is not having so much strength. In order to detect the fault or the quality of railway tracks or any bridges or any infrastructure, we can make use of ultrasound. So ultrasounds can be also used for detecting the strength of any such like buildings, railway tracks, bridges and everything. Okay. Not applicable in Bihar. Okay. So in that there is a different story altogether. Okay. Now, it is also used for sonar system, sound navigation and ranging, in order to detect what is present at the sea level. We cannot go inside it. So there is one simple option. We are using sonar waves to detect what is inside our sea. So when we have the sea floor mapping in 1950s, when we were able to detect this one part, that at the sea floor we are having some mountains, we are having some trenches. At that time we have not gone in 5000 meter deep or 10,000 meter. At that time we have used sonar for understanding the sea floor mapping. You may have read sea floor mapping theory in geography. Okay. So when we have estimated that at the sea floor we are having some sea mounts, some guyets, some trenches, some abyssal plains. So all these things have been possible because of sonar. When we are able to detect what life forms are present over there, the life forms are also detected because of the sonar. When we see a submarine coming up, we use the sonar system. So sonar is having usage in detection of the sea floor, in detection of any incoming threat or living organism also. So here also we are using the same ultrasonic waves for detection of the sea floor. So write about this ultrasonic wave and application. It refers to sound over 20 kilohertz. It refers to sound of frequency. It refers to sound of frequency above 20 kilohertz. It is used for the following purposes. First, in health sector, it is used for diagnosis of any abnormalities, inside the body, or information about fetus, information about fetus, information about fetus. Fetus is the unborn child. Information about the fetus. Second, it can be used for cleaning of ultra sensitive equipments and cables, It can also be used for detecting any fault in infrastructure, or assessment of its quality, For example, fault detection in railway tracks or bridges. For example, fault detection in railway tracks or bridges. Railway tracks or bridges. Fourth part, it is also used by the ships, submarines. It is also used by ships, submarines, etc. for mapping of sea floor, exploration of marine biodiversity, for mapping of sea floor, exploration of marine biodiversity, or detection of any threats, or detection of any threats. Or detection of any threats. Okay. So that is one part, like what is the application of ultrasonic sound. Now there is one thing, Doppler effect. So what is Doppler effect? Like this is one of the property of almost all the waves, including sound and others. So what is Doppler effect? This is connected to light also. We have not discussed in light. We will discuss it here itself, that what is Doppler effect, and then we will see its example in light also. Just to see this one simple example. Suppose you are standing on a roadside and an ambulance is approaching you. This ambulance is approaching you. Okay. You will find that when it is coming towards you, suddenly its sounds start to become very high pitch, means it will become very shrill, and at the same time the intensity is also going to rise. Okay. Means its frequency and its intensity both changes. Its shrillness, its intensity, both are going to be changed. So now the question is, why there is a change in this sound? Why it appears to be very much shrill and very much intensive? And as soon as it passes through you, or if it is standing still over there, you will find it is not so shrill. Like if an ambulance is in a standing position, if it is not moving and you are just in front of it, you will hear its normal sound. But when it is moving towards you at a very high speed, then you will find it to be very shrill sound. You will find it to be very shrill sound, very intense sound. And as soon as it passes you, you will find that the sound suddenly becomes low pitch. The sound becomes like a soft. It has lost its intensity or it has reduced. Okay. So why does this change takes place? Just see, what is the, let's say the speed of sound is 340 meter per second. Okay. And let us assume this, that the vehicle is also moving towards you at a speed of near about 30 meter per second. Okay. If the sound is also moving here, the sound is generated at a speed of 340, and at the same time it is coming to you, the vehicle is coming to you with a speed of 30 meter per second. So what will be the relative speed? What will be the combined speed of both of them? 370. So when it is coming to you, its speed becomes 370 meter per second. But when this passes you, sound is again going, or sound is coming to you at a speed of 340 meter, but the source is going away at 30 meter per second. So then what sound you will listen? What will be the combined speed? 310. Because when it is coming towards you, it will be added, it becomes 370 meter per second. When it is going away from you, its relative speed decreases up to 310 meter per second. So due to this speed, what you are listening here, you are listening sound like this over here, and when it passes you, the same sound becomes this. Its intensity, its amplitude changes. When the sound is up, when the sound on a source which is moving towards you, when it reaches towards you or when it is approaching you, it will have a higher amplitude, it will also have a higher intensity, sound will be very shrill. But when it passes you, then you will find that its shrillness has reduced, its intensity has also reduced. So this is one thing which we call as Doppler effect. Now tell me one thing. Here we see that there is a change in frequency. In this part you can say there are multiple waves, but here we see only some wave. It means frequency has changed. In light, we see that different frequency means different color. Light, if we see the 7 colors, Vibgyor, all of them have different frequency. Okay. They have different wavelength, it means different frequency. So now tell me, if they are using red color of light in the headlight, if they are using red color in the headlight, and when it is approaching towards you, then when you are looking at this ambulance, what color would you see? Red or orange, yellow or green? We know that red is having lower frequency, then we will have this orange, then we will have this yellow, then we will have green. It is having lower frequency. They are having higher frequency. This is also having higher. So now when a vehicle which is having red headlight, it is moving toward you at a speed of 30 meter per second. So what color would you see here? Red color, orange color, yellow color, or green? If a vehicle 30 meter per second, you can like change it in terms of kilometer per hour. 30 meter per second means what you have to multiply it with? 5 by 18 or 18 by 5? 18 by 5? Okay. So you have to pass CSAT, you have to know that. Okay. 6, 18 6 times? 18 6 times 72. 108. So let's say it is coming at 108 kilometer per hour. Very high speed. This is having red headlight. So what will be the color which you will see? Red, orange, yellow, or green? Green. So let's increase the speed. 60 meter per second. Now, what will be the change? Which color you will observe here? No color. Red only. See, you have to understand one thing. Sound has a speed of 340 meter per second. Light has a speed of if you add 30 in that, or 60 in that, or 80 in that, or 100 in that, or 1000 in that, there is no impact. Okay. Light is having a speed of 3 lakh kilometer per second. You can add 3 more 0. That is the meter per second. Okay. So light is having a speed of this much. Okay. So if you add 30, 40, 100 in that, suppose a person is having 3 crore rupees and you are giving them 100 rupees. So what they will do with that 100 rupees? Or someone is having 30 crore rupees and you are giving them 100 rupees. If someone is having 300 rupees and if you are giving them 100, that matters. But if someone is having like 30 crore rupees and you are giving them 100 rupees as donation, so that is the change here. Okay. So here we are not going to observe any shift in the color. The red will be red only. But change the reference here. If it is a galaxy, which is very far away from each other, so in that case, what we are going to observe, that one part will be visible as red and the other part will be visible as blue. Okay. Like suppose that we have a galaxy here and we have another galaxy over here. They are separated from each other. They are separated from each other by 1000 million light years. Okay. Or let's say 1 million light years. They are separated from each other as 1 million light year. 1 million light year. So in that case, they are moving away from each other. They are moving away from each other at a speed of 1.4 million light year per year. Means their distance is growing more than what light can travel in 1 million year. Okay. So their speed is almost 1.5 times greater than the light if they are separated from each other just by 1 million light years. Okay. And if you see the expansion rate It is just 0.007. At just this much expansion rate, the distance between them grows by 1.4 million light years. So when they are going away from each other, sometimes even faster than the speed of light, then in that case, you will see different colors over there. Even if they are moving at a slower speed, at somewhat slower speed also, then also when this part is going away, here they will see the red color, and the other side they are going to see the blue color. So this is one thing called as red shift and blue shift phenomena in the galaxy. So red shift and blue shift are also observed in galaxies. You will not be able to observe it on the earth. But in the universe, Doppler effect also exists in case of light. And that is called as red shift, blue shift. In the direction where galaxy is moving, it will be observed as blue light. In the direction from which it is going away, it will be observed as red light. Okay. So that is one thing. When we are tracking them, one side will appear to be red, another side will appear to be blue. When you look at the galaxies, you will be able to see them. So that is one thing. Light also has Doppler effect, but not on Earth, not in solar system. They have to be really very fast in order to show that. So that is observed in the universe only. So this is one thing called as Doppler effect. When due to the speed of the source, the frequency also changes. That is what we call as Doppler effect. So write about this. अब 30 करोड़ होने के बाद भी 100 रुपए लेके चॉकलेट खाएंगे. Write about this Doppler effect. When a wave producing object or source, when a wave producing source is present on a moving object, then you can say Doppler effect. In that is the example of Doppler effect. Okay. So when a wave creating source is present on a moving object, then the frequency and amplitude of the wave, is going to differ or vary in the direction of motion and the direction opposite to the motion, For example, if an ambulance is approaching towards a person, then the frequency and amplitude in bracket you can write pitch. Okay. The frequency and amplitude bracket pitch increases and the person is able to hear a shrill sound. The person is able to hear a shrill sound. But when the ambulance but when the ambulance passes that person, when the ambulance passes that person, then when the ambulance passes that person, then he would be able to hear a lesser shrill sound. Then he would be able to hear a lesser shrill sound. Like if you want to see the blue shift or red shift phenomena, like suppose here we are having a like a telescope which is observing the motion of this star. Yeah. When the star is approaching towards this, it will appear to be having blue. It will be appear to having blue color. But when the star crosses away from it, when it is going away from it, then in that case, the same white light will be visible in red color. So it is because of the movement respective to a particular location. If a telescope is here, it will be seeing this blue light because the star is moving in this direction. The movement of a star is also in this direction. And here, the light will shift towards the blue color. But if someone is observing from here, at this point, the star is going away from it, so then the red color will be visible, not the blue color. So it depends on the point of reference, that from what side we are seeing it. From one side, the red color will be visible. From another side, the blue color is going to be visible. So this is something which we observe in case of galaxies generally. Sometimes in a star also, sometimes in galaxies also. When a star starts orbiting around a black hole, then you will be seeing both of it. Just near this part of event horizon, we will experience both these things, that on one side it is blue, one side it is red. Like when we are observing it, there we can observe this blue shift and red shift in case of this star also, because they start moving at an enormously high speed. Then the speed is very high, very, very high. So that is blue shift, red shift, and Doppler effect. The next thing which we have to see is electricity and magnetism. We will see that part in tomorrow's session. Let me take some questions first. Okay. So now tell me, in any topic where you have confusion? So Doppler effect refers to this variation in the frequency due to the due to the location of the source. If it is located on a source which is moving in the direction of motion, the frequency becomes higher. In the direction opposite to the motion, the frequency reduces. This variation in the frequency is called as Doppler. In Doppler effect, it is very simple. In Doppler effect, what we see that, like suppose here we are having a ambulance is approaching towards a person. So these are the wave fronts. You can see that they are becoming closer. It means their frequency is increasing. The person who is here, he would be able to hear a shrill sound, and at the same time it will be quite intense. But you see on the opposite side, the waves are distant from each other. The waves are at a distance from each other. So here we will see that lower frequency, lower pitch, and as a result of that, shrillness of sound will be lower. So this change in the frequency of the sound This change in the frequency of sound is what we call as Doppler effect. In case of echo, what we see that echo is about the reflection of sound, the reflection of sound which we hear. Okay. Normally, we are able to hear one sound wave for 0.1 second. Like suppose if I am saying something, when it reaches to your ear, it is reaching to you like continuously from all the sides. Suppose you are on a speaker mode, so then the sound which is generated from the speaker is going to all the walls. It is getting reflected from there and reaching up to you. So suppose there is one person sitting here and a sound is coming from all directions. The same sound is coming from all direction. If it is coming within 0.1 second, he would be able to hear just one of them. But suppose that a sound is coming after 0.1 second from distant part. So then he would be able to hear the same sound again and again. So this reflection or this multiple hearing of the same sound wave is what we call as echo. If there are too many echo, we call it as reverberations. So it depends on this 0.1 second limit. It depends on this 0.1 second limit. We will talk about universe expansion speed later. It depends on the reference. Okay. If you look at the nearby areas, like suppose if you see that solar system or the Milky Way galaxy, is it also expanding at the same rate? The answer is no. But if you like see one galaxy and another galaxy which are at a distance of 1 million light years or more, there you will find that the rate of separation is higher. So it depends on the reference point. And universe is not moving, universe is expanding. When when light is passing through a medium other than vacuum, it shows wave and particle nature simultaneously as interact with. It can show both of the nature simultaneously. Yes, there can be like primary and secondary rainbow. We will talk about that. Like let me complete this part. I have given you some mains question to write. Maybe tomorrow we will discuss that. Difference between somatic and stem cell, long time. Somatic cell are the ones which don't divide to give different type of cell. Somatic cell are the normal cells of a body, like a skin cells. They are the somatic cell. They will produce a skin cell only. Stem cell is like hematopoietic stem cell. It can form RBC also, white blood cells also, platelets also. So that is called as a stem cell, which doesn't have its own function but can differentiate into multiple type of cells. It is used for ultra sensitive cleaning, ultra sensitive equipment. Like suppose we are having any such data centers and others, so they are having various components which needs cleaning from time to time. So that cleaning, like when we are passing the sound wave through a medium or through any object, it will start to vibrate. That vibration will lead to separation of the dust. Like you may have seen this one thing. Suppose you are using a cushion for a very long period of time. It has got a lot of dust. So how you will remove that dust? You have to just beat it up. When you beat it up, then there will be vibration. That vibration will cause the dust particle to come out. Like suppose when you are sitting somewhere ideal for some time, you have a lot of dust on you. Some friends come and punches you. Some dust particle may come out of you also. So I have explained this red and blue shift part. I hope now it is clear, Pratibha, what is red shift and blue shift? It can have different, like it all depends on the dispersion. I told you not that all the rainbows don't have the 7 colors exactly. Some may have 3 colors, some 4 colors. It depends which color of light has been dispersed, which color of light has got total internal reflection as well as refraction. So it depends on that. Plus, when it is coming towards you, there may be multiple obstructions, obstacles. So it depends on that as well. Angle of incidence, when suppose that here, this is the angle of incidence. Okay. That at what angle it is incident on the surface. Why the school bus is yellow in color? मेरा school bus red था. So I will not answer that. Okay. I didn't get a yellow bus, so hey, once we are doing this, Kuldeep, by tomorrow or by next 3-4 classes, we will complete this portion and then we will see the previous year questions of all of them. Okay. There are around 30-35 questions from the last 10 years. So we will see all of them. Okay. Now, we are able to see all the 7 colors. Like we are able to see red to violet. But generally our eyes has more sensitivity for blue color and above. Those who are having blue color, or let's say those who are having green, yellow, orange, red. So these are the colors which are more visible. Indigo, violet, they are comparatively less visible. The light with higher frequency are less visible. As you approach to ultraviolet, it is non-visible. Red shift and blue shift we will write. Don't worry about it. We have to discuss the universe also. So there when we will discuss this part, there we will see that. Okay, so if there is any more thing related to the things which we have discussed, ask me tomorrow once again in the beginning itself. Then we will meet tomorrow and discuss further things. Okay.